Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this video is part 8 of a continuing series where we're going to take a game called Boxxle / Sokoban and convert it into a full-on C++ SFML engine game. We've already, parts 1 through 4 or whatever, we've already taken care of the GameMaker side of things, and now we're working on the engine. We're still not into the game portion, we're still working on the engine. So just as a quick refresher, as always, you're a little guy, you're going to walk around and you can push blocks around, and the goal is get the boxes to their goals. And so the game's going to run in 720p when we get there, 60 by 60 tiles for everything. So what are we doing in this video? In this video, we're going to take a look at game objects. So we're going to create an SFML object class. And just like in GameMaker, object is the overarching resource for everything that is objects that get put in the game. And we're going to do the same thing. And then we're going to update the game class to accommodate it. Surprisingly enough, or maybe surprising or not, we actually don't touch the game class in this video. We touch the room class and a few other things, but nothing like that. So that's what we're doing for today. So I already have all the files. There's 8 files that we're going to play with today. And so 4 object types, so 4 H files and 4 CPP files. And so here we go. So I have this overarching base class for an object. So we discussed this back when we talked about rooms, like what is common to every room. And then we discussed, and surprise or not, what you come up with is the object class is pretty much, obeys the same behavior. So the object class needs a constructor to construct everything there is to worry about when it comes to being an object. And right now there's nothing, but we're saying we're going to fix that up. There, again, we're still working our way through. There's more. There's not a ton of stuff more to do, but there's enough that we have to do. And we will be adding stuff to this, like a sprite class. A virtual destructor. Again, this is a base class for everything that's going to be an object in my game. So I need this so that I don't have a memory leak when I go to destroy my objects later on. And then a step and a draw event, just like the room has a step and a draw. And so now what's going to happen is the room is going to call the step for every object in its environment. And it's going to call the draw for every object in its environment. And so it's virtual so that I can override. And so again, right now, just like last time, like these are just going to be empty shells for now, but just say we will fix these up. Constructor, destructor, step event, and draw event for these types. Okay, so object, there is the overarching object. So I keep promising we're going to move that circle shape and kill it off and get rid of it. We're one step closer, but I moved it out of the room now, and now I moved it over into an object that is, basically a derived object. This is our first opportunity to look at how the derived object classes work. So I don't need to worry about destructors for this circle shape because it's not newed up. The memory is static when it comes to that. So the circle shape has a constructor, it's overriding the step and the draw, because when we first started, all this code was in the game class. Remember, this all started out as this code sitting in a main function somewhere, and we've taken it and we moved it like 2 or 3 times now, probably 3 times now. And so the step event will take the shape and it'll fill the color in. So again, it starts out white, so if it turns green, I know my game is working, my program is working. And if I draw it, then I know it's drawing and I know it's working properly as well. And here's the constructor for this guy. And so this is as far as things are going to go. And once we have a sprite class and all of this stuff, we can finally put sprites and objects up. We can finally kind of just dissolve the circle class into nothingness. But again, this is just very basic stuff. I don't need to worry about the destructor here, but I take over everything else. I have to have a constructor. I have to call up, create a shape here to create and give it the 200 pixel radius that it deserves, the step event for the fill color, and the draw to actually physically draw the thing on the screen. So every time you do this, and so like you said, just over time, take it as it is. If you need to do something in a step event, or even like the draw event, most likely we will never need to override once we get this thing going, because everything in the draw event will be, just like in GameMaker, will be done automatically and in that draw event. But if we need to take over, just like in GameMaker, sometimes we need to take over and still do more than just what the object draws by itself. We have that opportunity to do that because we can override the draw if we need to. because that's the whole point of this, right? Oh, you know, like virtual polymorphic functions for every major task that the game object can do, and that room can do, and the game can do. Okay, so and every object is going to follow this theme. Give me a constructor to get everything going, and then basically a lot of it, most of it is going to be handled in a step event. GameMaker has a lot more different events, but we're going to kind of just jam them all into one catch-all when it comes to step. And most engines do that. GameMaker is kind of unique that it has all those different events, which is great, but sometimes it hinders because especially when you're like, well, what operations and what events trigger before other ones? There's no, you'd have to go through an experiment to find out exactly the order. But if I put things top to bottom inside of the step event, I control those actions instead of allowing GameMaker to fudge with those factors. Okay, so that is everything when it comes to just setting up the object class itself. So then now what did I do to accommodate for this? So I say like the room class has been completely updated. So now you can see this is no longer clear over here. Oops, that. Okay, so you can see here, what do I have? The room class has its constructor, has its destructor, has its draw and step, and now instead of having nothing here, now I'm maintaining a vector of SFML objects under the hood. So I said the vector is the simplest idea. If we wanted to make things more complicated later on, like if we ever wanted to create like a quad tree, something that could, you know, break down a space and put objects in a way into our space in a way that when we want to decide if there's collisions, we can do that as efficiently as possible. We're not going to worry about that probably. I only got 2 weeks to get this done, and every other class I teach here, it's pretty daunting. So we're just going to stick with the vector to start. It's a vector of object pointers, and I'm just going to call it objects. And so setting this thing up and getting going with it. Oh yeah, and then there's also going to be a function because once we have a room, we need a way to place objects into the room, right? It would be pointless if you had a room and we did all this hard work and we have a zero-sized vector of objects to, you know, just to draw and update and do all the things that our game is going to do. So in this case here, so this instance create function takes in a pointer to an object and then it basically pushes it into the vector. We'll see that in a couple minutes here. So okay, so here the objects are, you know, this is now part of the constructor just to set up a blank list. It's unless you know, it's one of those things, if you really knew how many things to reserve, how many objects to reserve, you could go ahead and do that. But for the most part, you know, just kind of let it go, because that's what that loading screen is all about, right? A couple milliseconds, you're not going to notice, but you will notice, you can notice that jarringness if the game is running and you notice that little, you know, that the game chugs a little bit. Okay, so then the destructor, because we have a vector of newed up, everything is new coming in. So you'll see there's no newness. This is where things get a little weird sometimes, right? This is where you can maybe see the complexity of memory leaks, is that we're going to new stuff up in many different places that are, you know, that are completely unrelated. Like I'm going to new up this object and new up that object and new up a bullet and new up a bullet and new up a this and an explosion and a this and that and destroy things and all sorts of stuff. But the problem comes down to, when it comes down to it here, is the deletion occurs here and only here when the room ends and the room is closed off. So new all over the place, but everything is deleted here. And usually almost every other time you see this stuff, you see the new and delete in the same scope when it comes to our code scope. But in this case, it doesn't work that way. We new stuff up everywhere else and then we delete it in here. But for every object pointer, delete, and then just for safety's sake, clear out and just bring back the pointer and just make it an empty vector. But I have to do this delete. The clear does not go in to each pointer and delete the memory stored with it. Okay, and then step and draw are very simple. I mean, once you're used to the range-based for loop, all I'm doing for every object in my scene, in my room, do the step event. For every object in my scene, do the draw event. So the order does matter here. So like maybe eventually we'll fix up a depth ordering, just like we did in the game, so that certain objects draw before certain other objects, because otherwise the order in which we put them in the room matters. And that is a complexity we do not need to worry about. That bullets, you know, like sort the bullets and do this and that. No, it sounds crazy. Let's not do that. But if we set up depth ordering, it's possible to very simply, just like in GameMaker, just simply sort the drawing order. Okay, and as you see here, this instance create function down below, it just takes in a pointer to an object that we will new up somewhere else, and it just basically pushes that pointer onto the stack. So the idea is you new stuff up in a different place, and then push it onto the stack, and then when the room deletes, the room is the one in charge of deleting everything and making sure everything is put away. So for now, that is pretty much all we need. Eventually, we're going to need like a change room function and maybe a few other things, because we're going to need to say like, oh, I'm in the main menu. Oh, I want to play level 1 or level 2 or level 3 or whatever it is I want to do. I want to switch from room to room. But right now, this is the bare bones minimum just to introduce the topic here of the object class. Okay, so coming back, the final thing I did here is in this game initialization room is to set up and actually be able to use this circle shape. So I modified even that, and now I promised you a little bit before that I was going to say we can get rid of all of that extra stuff. And now that we're moving on into the object phase, you know, like worrying about the objects and now the sprites and the textures, that I don't need to have the overrides on the step or the draw events. So I took, you know, all that code had to do with specifically that circle shape. So once I dragged that code out and moved it over into the circle shape by itself, there was nothing left to do. And so I don't need to worry about those virtual functions. So the only thing left to do then is the constructor, because the constructor is where basically we're going to set up and go new, all the objects in my game scene. And you can see that here. I have my instance create where I'm saying, give me a new circle shape, and you got to include, of course. Give me a new circle shape, and then pass that along and put that object, since it new returns a pointer, right? It's right here, new void pointer return. So it's going to pass a pointer along and push the pointer onto the vector inside of the room class. And still, like I said, like ultimately we will still kill this thing, and ultimately the only point of this kind of stuff, like in the initialization room itself, is to set up the textures, and then the other rooms will actually go ahead and use the objects that are going to use these sprites and textures. So again, we're still a step or two away from the true powerfulness of all this, and once it comes together, it's beautiful, and it's just how little amount of code you have to write. So, you know, we're spending our time and efforts up front, so it's real easy on the back end, pushing forward to make our game. Well, let's see. That's pretty much it when it comes to just setting things up for now. Oh yeah, just to prove it, here is there's my green circle, and just to show circle shape draw, I can put a breakpoint in it. There it hits it because it's running the code through. And it's pretty cool, right? If you want to think about it, like what's going on, just go back to the game object, right? The game object, maybe I can pull that open right now. Let's see, get to the Solution Explorer, give me the game.cpp. So like here, when it goes, I'm in this loop, right? This loop is running, and something like this, a draw event. So I go, okay, the draw calls this function, and then it goes into the room, and then says, okay, room, draw yourself. And then the room says, okay, for every object, draw. So then now I'm in the circle shape. And I would go into every object's draw polymorphically to figure out what to do next, what to draw on the screen, or what to update in the step events, and so forth and so on. So it's like, you know, like we've delegated to delegate, and now we're spreading across all these function calls. And it's really cool how it all works together. Okay, so I'm done with this stuff. I'm going to give another quick, just a quick review, another description one more time. So if you're good with my explanation, then you are done. Thanks. See you next time. But otherwise, stick around here. So one more time, what did I do today? So I have my, oops, where did my object? There's my object. Okay, so my object class looks very similar to my room. At least last video's room. I have my constructor, my destructor, virtualness, because it's a base class, step and a draw, because that's pretty much all for now we're going to worry about. So right now, we're not doing anything with it because that's another video to set up the texture manager and the sprite manager and get that going. But we need this because that's our base class, and this is our architecture. This is our foundation for all the other objects that come off of it. So the circle shape then takes over for this. It doesn't need the destructor, but it needs the constructor, and it's overriding the step and the draw. We showed earlier that this is working. Everything's working through. So we set up this shape object, set the fill color, and set up everything so it can draw the shape to the screen. And so now this is where specifically the code for that shape is. It's moved 3 or 4 times now. but that's how everything goes. And then so now one more time here, I have taken the room and set up. This is where the majority of the work went to, where I've updated so that I have a vector of objects sitting under the hood. I have an instance create function that I'll put in because if I don't register these objects in the room, they'll never draw and they'll never update, because that's you have to register them with the room for them to do the job. Otherwise, it'll never work out. So I have these two things, but now you notice again, every function in here had to have been touched. I added the constructor to objects to the main constructor for the room. I added a range-based for loop to delete every object on destruction. I added a range-based for loop so I can call a step event on a step event. And I called for a draw the same way, a range-based for loop. And then the instance create function takes in a newed up pointer from somewhere else and then puts it into the vector right at the back of the vector. And then later on, when this thing is destroyed, it's the understanding that it's the room's responsibility to destroy all the objects that were created while the room was in action, while the room was active. Okay, and then the final step was that first room, the game initialization room, I took over and moved some stuff around because all of the code basically was for that circle shape, and since I moved everything into circle shape, now all I need is a constructor that basically sets up and tells the room, hey room, put this circle shape in, and eventually we'll see that once we can get into the step event and start doing stuff, you'll see that the step event is where all the real action will take place inside of the game objects, and we'll start moving away from touching the game class we won't even touch, and maybe even the room class we won't even touch. We're moving away, we're adding these layers of abstraction and making this thing more powerful. All right, so as always, swardb@cod.edu is my email address if you have any questions. Did I do something wrong? Did I say something wrong? I don't know. I'm 17 minutes of doing my best here. So, or send me a comment here on YouTube, and we'll be moving on in the next video to sprites and textures. Thanks, everybody. See you around.